two identical cylindrical vessels are kept on the ground and each contain the same liquid of density D. The area of both the bases of the vessels is S, but the height of liquid in one of the vessels is x1 and in the other x2. When both cylinders are connected through a pipe of negligible very close to the bottom, the liquid flows from one vessel to the other until it comes to equilibrium at a new height. The change in energy of the system in the process is potential energy is given by mgh, mass is density into volume. So the initial potential energy density into Sx1, which is the volume, into the height x1 by 2, which is for the center of mass. This is for vessel 1, and the Sx2 into x2 by 2 for vessel 2, whole into G. Now both the vessels are connected, so the new height is x1 plus x2 upon 2, and the new height for the center of mass is x1 plus x2 upon 2 upon 2, which is x1 plus x2 upon 4. So the final potential energy is equal to ds into x1 plus x2 upon 2 into x1 plus x2 upon 4 into 2, because there are two vessels, into G. Now ui minus uf is simply G x1 square by 2 plus x2 square by 2 minus x1 plus x2 whole square upon 4, which is simply the formula for x1 minus x2 whole square upon 4. So we have dsg into x1 minus x2 whole square upon 4. So the correct answer is option 3.